Welcome to our second episode on energy losses and efficiency. If you haven't listened to the first one, I recommend you go and have a look at that first. So, if you want to reduce unwanted energy transfers, there's a few steps you can take to do so. So the first one is using lubrication. So lubrication reduces frictional forces. A moving object normally has at least one frictional force acting against it, and that causes some energy to be dissipated or lost. Lubricants can reduce the friction between the surfaces of objects that are rubbing together, and lubricants are normally liquids to help with that. Another way to reduce unwanted energy transfer is through thermal insulation. So heat will be lost through the roof, windows, walls and floors of a house, but to reduce energy transfer, we might put loft insulation in the roof, we might use double glazing in the windows, we might use what we call cavity wall insulation in the walls, so that's just an insulation that goes into the walls. And we also might put carpets on the floor, which help insulate the floor. And a final example are the walls in homes. So we can decrease the rate at which a house cools down by either having thicker walls or having walls made from material with a lower thermal conductivity. So that means it will be able to conduct heat a lot less well than something with a higher thermal conductivity. So the more heat that a material conducts, the higher the thermal conductivity is, and the higher the rate of energy transfer by conduction across the material. So some ways to reduce unwanted energy, just to recap: thermal insulation and lubrication. And we can reduce unwanted energy transfer by those two methods. So thermal insulation, we can look at reducing heat loss through roof, windows, walls and floors. And lubrication reduces the friction between surfaces when two objects are rubbed together. So some ways to reduce energy lost through walls in the home. Well, firstly, you could have thicker walls, and secondly, you could have walls made from material with a lower thermal conductivity. You also need to know about power. Now, power is the rate of energy transfer to a component, and this is the same as saying power is the energy transferred per second. Now, it is also equal to the rate at which the work is done. So the equation for power is energy transferred divided by the time. Now, the units you need to know are power in watts equals energy transferred in joules divided by time in seconds. You also need to know the equation for power in terms of work done. So again, power in watts equals work done in joules divided by time in seconds. And what you can take from that is the energy transferred is the same as the work done. Now, if we've got a question we want to ask in an exam, a speaker receives 20 joules of energy over a period of 5 seconds. You need to think about what is the power. So remember that the power is the energy divided by the time. And we know that the energy is 20 joules and the time is 5 seconds. So we do 20 divided by 5. And that gives us a power of 4 watts. Remember, the units is watts. And remember also from earlier that lubrication reduces frictional forces, and that we've got the power equals energy divided by time. Now, another calculation for us to work out here. So if a current flows through a light bulb, it emits 30 joules of light energy in 2 seconds. What is the power of the bulb? Well, remember, power is the energy divided by the time. So 30 divided by 2, which gives you 15 watts of power.